We are back for the third and final video of today, and this is the Punnett Square number 3. Now, as you can see here, like in the last video, we have our parents up top, but unlike the last video, we have words in describing the parents instead of the actual letters, describing it with the phenotypes. So as you can see here, we have hybrid green pods and wrinkled crossed with true breeding round and yellow pods. Now, our first question is, what is the dominant phenotype for the first gene? And now that would be green. Because looking back on the Mandel's P traits, green is dominant. And as you can see here, it's hybrid, so that means that there will be a capital letter and a lowercase letter. And now, the recessive phenotype for the first gene is going to be yellow, just like up here. So we're going to put yellow. And that is the recessive trait for the pod color. And now, the letter that we're going to use is G. Now, what is the dominant phenotype for the second gene? And what is the recessive phenotype for the second gene? Now, as you can see here, we have wrinkled, and then true breeding round. And true breeding just basically means homozygous. And round is our dominant, and wrinkled would be our recessive. So we're going to write that. Round, and then wrinkled. Now, what is the letter that we're going to use for this gene? And that's going to be R. Again, because R, or round, is the dominant phenotype. And now the genotypes of the parents are in capital G and lowercase g, and then 2 lowercase r's. Because just like up top, we have hybrid green pods, and this is a hybrid right here, and then wrinkled, which is homozygous, because that's what it is assumed, because there is no clear stating which one it is, but it is a recessive, and so whenever there is not anything in front of it, it is automatically homozygous. And now the second one, you're going to have 2 lowercase g's, and then 2 uppercase r's. Again, all in alphabetical order. Now, down below we have gametes for parent 1, and then the gametes for parent 2. Now for the parent 1, is going to be capital G and lowercase r, and then comma, we need that comma there. That is very important. And then 2 lowercase g and r. And over here for the gametes of parent 2, this one is simple. It's just a lowercase g and a capital R, because that's all we can get out of that one. And now we are going to go on to the Punnett Square. Now this Punnett Square is going to be very, very simple. It's just going to be like that. And we're going to have this one right here go on to the top. And we just split it in half and we just bring those to those sides. And just like in the last video, we're going to fill in the Punnett Square accordingly. There we go. Now that we've filled in our Punnett Square accordingly, we are going to answer the questions down here. Now the first question is, what fraction of the offspring will have green pods and wrinkled seeds? Now the green pods are dominant and the wrinkled are recessive. So as we look up here, we need to find one that has the capital G and 2 lowercase r's, but I don't see any up there. So So because it's out of 2, we would just put 0 out of 2. Or we can just leave out the 2 and just put the 0 if we want. Now the second question is, what fraction of the offspring will be dominant for both traits? Now as we look up back to our Punnett Square, we can clearly see that both of those are dominant, but this one is recessive and this one's dominant, so we're only going to have half, which is just 1 of 2. Now the next question we have here is, what fraction of the offspring will show the dominant phenotype for one gene and the recessive phenotype for the other gene? And as we look up, and we can see that only one of them out of the 2, so it's going to be again 1 of 2. And the very last question that we have today is, what fraction of the offspring will be dihybrid? And we look up here, this one is clearly a dihybrid because of the capital then lowercase, capital lowercase of the genes. And then this one we have a full recessive and then a dominant, so that is not a dihybrid. And I explained dihybrid before in my previous videos. So it is again 1 of 2. And that is it for today. Thank you.